Today we're going to be talking about radicals. The radical is that little symbol out there, the square root symbol. So we're going to be talking about radicals today, and it's my favorite symbol in math. That it's like a check mark, but a squiggly, like together. I think it's cool. And of course, inside of the radical, you can have any kind of number. Actually, you can even have variables too. And let me put one in there like this. Remember, that means that there's some unknown number, and it can be anything. And so sometimes with radicals, you're trying to figure out what is that unknown number. It has a really cool name. Do you know what this thing's called inside of the radical? This, whatever is in here, the x or the number, whatever it is, it's called a radicand. Is that weird? Radicals and radicands. So today, your purpose today is to be able to simplify radicals and actually add and subtract them too. And we see radicals come up a lot. Actually, you saw them come up a lot with the quadratic formula. Almost every time you get to the end of a quadratic formula, you have a radical. You see them come up even more in geometry next year. So there's a special way you can actually handle them. You don't always have to just go to your calculator. And that first thing we're going to talk about is simplifying. Let me give you an example. Let's say, and notice I wrote simplify over here, but I'm going to put my number actually right. I'm going to move it over just a little bit, kind of right here. Let's say we're going to take the square root of 160. Do you know what that is? Do you have it memorized? Probably not, hopefully not. What we want to know is what two numbers multiply to make 160. Someone might say it's 40 and 40. It's not 40 and 40. That'd be way too big. It's something else. And so what we can do is we can go through and we can simplify a radical to help us figure out what it might actually be. And it's a better way to write it, kind of like the way you simplify fractions, you simplify radicals. And what you want to do is you want to figure out what gets multiplied to make 160. And so what we do is we break it down into its factors, like this. You just start with the lower numbers and start working your way up. I think, can I divide it by 2? Yes, I can. If you multiplied 2 and 80, you would make 160. Those are the factors, one of the factors. The 2 is a prime number, and today you're going to be trying to find all the prime numbers. What I want to do now is I want to break apart the 80. What are the factors of 80? Can I divide by 2? It sure can. 2 and 40 would make 80. Is this starting to remind you of something that you've done before? They're called factor fireworks. You learn about them, I think it's like 5th grade or 6th grade. We're breaking apart a number into all of its prime factors. Can we break apart the 40? Yes, we can. 2 and 20. Can we break apart the 20? Yes, we can. 2 and 10. And can we break apart the 10? Yes, the 2 and 5. So when you're simplifying a radical, the first thing you do is you go through this factor firework and you find all the prime factors. And this is kind of cool. If we multiply the 2 and the 2 and the 2, if we multiply all of these here, we should get back to 160. Let's see. 2 times 2 times 2 times 2 times 2 times 5 is 160. Yep, we did it right. Now, the square root, the radical, means what two numbers multiply to make the thing inside. Today, we're going to be thinking about it in reverse. We're going to think about if you have 2 of the same numbers inside, then you can take one of them out, like this. I'm trying to pair up all of our prime factors. we have one pair of 2's. Here's another pair of 2's. So inside of this radical, we have 2 times 2 times 2 times 2 times 2 times 5. But if you have pairs, then you don't need to leave them inside anymore. I like to think of them as like they're escaping. 2 times 2 is 4. And what is the square root of 4? 2. So what I have here is I have a 2. And I have another pair of 2's. They're going to get multiplied. And what I have left is going to go inside. I had a 2 and a 5 left over in here. So this is the way simplifying works. I pair up my prime factors, and if there's a pair of a number, then one of them can escape. If there's anything left over, they stay inside. And now I can simplify this. 2 times 2 is 4, but I still have a square root of 10. This means 4 times the square root of 10. If we did it correctly, 4 times the square root of 10 should be the same as the square root of 160. Let's check. The square root of 160 is that decimal number. 4 times the square root of 160, or not 160, sorry, 10. 4 times the square root of 10, it's the same number. So we successfully simplified the square root of 160. All of them work the same way. You take the number inside and you break it down into its prime factors. And then whenever you have a pair of prime factors, one of them can escape. It's kind of like the 2 become 1. There were 2 2's, but now you only have one of them. It's because you're taking the square root of 4. The square root of 2 things that are the same is just one of them. So we have one pair of 2's, another pair of 2's. That's how we got these on the outside. And then inside, we're still left with a 2 and a 5, and everything's just getting multiplied. Okay, let's try another one. Square root of 54, let's say x to the power of 7. In geometry next year, you're going to find some variables sometimes inside of these radicals. And what we want to do is we want to simplify it. So inside here, we have 54 times x times x times x times x, all those, right? So let's start by breaking the 54 into its prime factors. You can divide by 2. My brain is not working today. What is 54 divided by 2? Oh, 27. 2 is prime, so it's done. You can circle it if you want. The 27 can't be divided by 2, but it can be divided by 3. That would be 3 and 9. 3 is a prime, so we circle it. And then the 9 can be broken into 3 and 3. And those are both prime. So there's the prime factorization. 2, 3, 3, 3. And you can always check your work. 2 times 3 times 3 times 3 is 54. We did it correctly. You know what you do with the x's? Kind of the same thing, but you're gonna break them all apart. The x to the power of 7, that's x times x. There's 7 of them. There's 4, 5, 6, 7. Now, the way we simplify is the same as before. You look through the prime factors and you find any pairs. I see one pair of 3's. That's it. So what that tells me is there's going to be a 3 on the outside of my radical. And on the inside is everything that was left over, a 2 and a 3. Like that. Oh, but I also have to deal with the x's this time. And this works the same way when you have a variable inside. If there's a pair of the same variable, then we can take one of them to the outside of the radical. So there's one pair of x's. Here's 2, and here's 3. So on the outside, we not only have the 3, I'm going to erase it and move it over a little bit. We also have 3 x's. like that. And on the inside, we had one x left over, so there's still one x on the inside. Now we just do a little just normal simplifying. 3 times x times x times x is 3x to the power of 3. And on the inside, 2 times 3 is 6, and we still have one x left over. So this would be our answer here. The reason we're finding pairs is because the square root says a number times itself. If you have that, then the answer is that number. And so here was an x times itself. And so the square root of, or the square root of that is just an x. Okay. Let me give you one to try on your own and we can see if we get the same answer. Okay, try this one. We'll call this number 1 then. See if you can simplify the square root of 72. I'll give you a minute, go through all the steps, kind of like we did before, and we'll see if we get the same thing. Here you go, here's your answer. Sorry, I started to write it. I didn't mean to show it yet, but I showed it, so there it is. Maybe you didn't finish, but were you on the right track? When you do the prime factorization, you find one pair of 2's and one pair of 3's. So on the outside, you have a 2 and a 3. That's where a lot of algebra students get confused. You had 2 2's, but on the outside, you only write one of them. And it's because you took the square root of 2 2's to get it to the outside. Same with 3's. So you had 2 3's, so now you just have one, but it's on the outside. And you can always check if you wanted to in your calculator, is the square root of 72 the same as 6 times the square root of 2? Yep, they're the same. Let me give you another practice one, and this one I'll make sure to give you more time on, okay? We'll call it number 2. We're going to start with a number on the outside. Well, it's going to be a variable. Let's say we have negative x on the outside. Square root of 80 x to the power of 9. If you find some shortcuts, go ahead and take your shortcuts. I'm showing every single step, but as long as you're showing your work, you can still solve these without showing every step as you get more comfortable. If you're not comfortable with that yet, then just keep showing every step like I've done. So negative x on the outside, square root 80 x to the power of 9. This one is a little weird, but it still works all the same. You break it into its factors and figure out what's on the outside, what's on the inside. Then at that point, it's just multiplication. All right, let's see if we got the same thing. You break apart the x's. You break apart the 80. And so you end up with something like that, right? You have two 2's on the outside, and then 1, 2, 3, 4 x's on the outside. Don't forget about that negative x was out there at the beginning though, okay? And then on the inside, you have 5x. So when we put it all together, your answer is this. The 2 times 2, that's where you get the 4. It's negative because remember at the beginning there was this negative x. And then now you don't have 4 x's on the outside, you actually have 5 of them. Okay, so as you're able to move things outside of the radical, they're just getting multiplied. And if there's something already out there, it just gets multiplied too. Questions, comments, concerns, wonderings? Yeah. With everything that's on the outside. Because it was already on the outside. Yep. If you want to, you could even like circle it and draw it to wherever you need it to go. Like when I solve these, I do what I showed you. I break it into my factor firework. I list all those out. But then the first thing I do when I start to write this out is I look back and like, okay, was there anything out in front? There was. So let me just put him right there so I don't forget about him. And then I deal with everything I was working with. Good. Any other questions, comments? Okay, I'm out of room, so I'm gonna have to flip my paper over. You run into this simplifying when you're dealing with the quadratic formula, when you're dealing with this thing called Pythagorean theorem. It shows up a lot in geometry. Okay, so let me show you something else. That's simplifying. And on your homework today, you're going to have some simplifying. But your purpose today is also be able to add and subtract as well. So let's talk about how that happens. Okay. So we're going to make a little section here. We're going to call it, we'll just say add. That's how you simplify. Now let's talk about how we add. Let's say we did this simplifying, okay? And we ended up with an answer that looked like this. 6 times the square root of 11. That's nice, it's already been simplified for us. But then let's say we had to add it to 9 square root of 11. Well, you treat the square root of 11 as just like its own number. It's a number, right? The square root of 11 is something. We don't know what it is, but it's a number. So this is 6 times a number plus 9 times the same number. So what do you get when you add them? You get 15 times whatever that number is. 6 times something plus 9 times the same thing is just 15 times whatever that thing is. It's kind of like adding a variable. Is that the connection you made? Yeah, right? 6x plus 9x is just 15x. Because x could be square root of 11. Who says x can't be a square root? What about this one? 3 square root of 5 plus 2 square root of 4. Well, this would be 3 times a number plus 2 times a different number. Or if you want to think about the variables, 3 times x plus 2 times y. You can't add them, they're already done. You can only add them if the number, if the Radicand is the same. If it's not, then you can't do anything. You just have to leave it like that. They're not like terms. They're not the same thing. I think, yeah, I want you to try one here. This will be your chance now. 5 square root of 5 plus 2 square root of 5. Five x plus 2x, same thing. Well, it's just 7 square root of 5. Isn't that nice? You sometimes algebra and geometry students think like you see the addition with the radical, you're like, uh-oh, this might be kind of tough. It's not. If they're the same, you add them. If they're not, you don't. But what if we had a negative number? Well, a negative number it's the same as subtraction, right? Like that was 5 plus negative 2 square root of 5. Well, that'd be like you're subtracting it. So that'll be your next section. What if you had to subtract? Subtracting, or what if you were adding a negative? Same thing. Well, it looks like this. Five root 3 minus the square root of 12. Now, there's an extra step in here. The 5 square root of 3, that you can already tell that's simplified. The 3 is a prime number, the 5 is on the outside, but the 12 isn't prime. We can simplify the 12 before we try to solve this problem. So we actually need to do our simplifying first. It'll look like this. Let's break the 12 apart. This would be 2 times 6. And the 6 would be 2 times 3. Now I have my prime factors. And let's see, we have a pair of 2's. So instead of root 12, we're going to have 2 times the square root of 3. So this problem is actually 5 square root of 3. That one stayed the same. That was already simplified. This is going to be 2 square root of 3. So when you're subtracting, this would actually come up in addition too. Before you can add or subtract, you have to make sure both radicals are simplified. Then you just, let's see if we have 5 times the number minus 2 times the number. Well, that's just going to be 3 times square root of 3. It works like addition. And after you simplify them, if they're not the same, you don't subtract them. You can only subtract them if the radicands are the same. All right, let me show you one more, and then we'll check in and make sure you're feeling all right. Let's take this one. 5 square root of 32 minus 4 square root of 18. The 32 and the 18, they're not prime. So I know that we're going to have to simplify both of these before we can subtract. So let's do the factor firework for 32. This would be 2 and 16. 2 and 8, 2 and 4, 2 and 2. Now I could just check my work here. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yep. And we pair them up. There's one pair, there's 2. So on the outside, we're going to have 2 times 2. And on the inside, we have a square root of 2. Did I miss something? Oh, yes, see? Oh, it's easy to forget about that thing that's out there at the beginning. That was not a planned mistake. I totally missed that. 5 times 2 times 2. Yeah, there you go. Good. Okay, now let's break apart the 18. 2 and 9, 3 and 3. So it looks like we have a pair of 3s. Okay. Oh, and there's a 4 out there in front. So this is going to be minus 4 times 3 square root of 2. This is about as long as they get. It's probably the longest simplifying subtracting problem you'll see. So now a little bit of simplifying before we subtract. 5 times 2 is 10, times 2 is 20. This is 20 square root of 2. Minus 4 times 3 is 12, 12 square root of 2. They're the same radicand, so we can actually subtract them. If they weren't, then you would stop here. But you can subtract them. 20 minus 12 is 8. 8 square root of 2. Yeah. If the 3 was a negative here, then it'd be a negative times a negative, so it'd be a positive. So it would change it to addition. Yep. All right, let's give you a practice one for subtraction. Here's number 1. Square root of 3 minus 5 square root of 3. We're going to do a couple of these and I'll send you on to your homework. If you have a square root of 3 and you're taking away 5 of them, you have negative 4 square root of 3. If you prefer, you could put a 1 out here in front. That doesn't change the value at all. That might help you. Because then you have 1 of the square root of 3s, you take away 5 of them, so you have negative 4. You just kind of think of it as like x's. 1x, take away 5 x's, that's negative 4 x's.